Hi, everyone. This is a brief video covering the chemistry of life or an understanding of chemistry that you will need to get through your basic biology courses. The chemistry here is going to be simplified and not anything like what you're going to understand if you go through a chemistry class, but hopefully it's a quick review of things that you already know so that you can remind yourself of important concepts to understand for biology. So chemistry is concerned with the composition of substances and how they change in chemical reaction. Your whole entire body is made of chemicals that's organized into things like organelles in a cell, and the cells are organized into tissues and so on. As well, all the food that you consume is made of chemicals. The medications that you take or will prescribe to patients are composed of chemicals. All of our physiological processes that we'll be examining are based on chemical reactions that are occurring throughout the body. This is the domain of biochemistry and physiology. And when you get into pathophysiology, you'll see what can possibly go wrong with some of those chemical reactions. So matter is anything that takes up space and has mass. It's composed of elements, and those elements can be in the forms of solids, liquids, or gases. Elements are the simplest types of matter that have specific chemical properties. There's 98 naturally occurring elements. The elements are made up of atoms. Atoms are the smallest particles that an element can have that has the properties of those elements. The atoms can then interact to form molecules. Atoms themselves are composed of electrons, protons, and neutrons. The electrons are negatively charged particles, and the protons are positively charged particles. The neutrons are uncharged. Do not confuse the neutrons that are neutral or uncharged with the electrons that are negatively charged. The protons and neutrons make up the nucleus of the atom, while the electrons will move around the nucleus in an electron cloud. We represent this cloud in models on our papers as orbitals. As I said, here's a picture of an atom. It is composed of the positively charged protons that are in the nucleus. And here's a proton right there. And the neutron, which is neutral or has no charge in the nucleus. The electrons are out here in the orbitals, and they have a negative charge. This model of an atom has one proton, one neutron, and two electrons. Let's see later on if you can figure out which element that one is. With these electrical charges, you have to remember that like charges repel each other and opposites attract. That'll get to be very important when we get into chemical bonding. Sorry, trying to dislocated my mouse here. Okay, here's another representation of an atom. You can see the representation of different levels of orbitals in this model of the atom. Here we have the protons represented by the light green in the center core, which are the positively charged particles, and the neutrons, which are uncharged particles in the nucleus of the atom. Surrounding it, first, we have one electron shell or orbital, which is the 2s orbital, if we're getting technical. And that contains 2 electrons, which is then filled. We then go to the next outermost electron shell, and here we see that we have 4 electrons in that shell. We'll learn later on that this is an incomplete shell. So all atoms have protons, and most will have about the same number of electrons as protons. This will keep the charge balanced so that the overall charge on the atom is neutral. The atomic number is the number of protons in the nucleus, and this will determine the type of atom and the type of element. So for instance, hydrogen always has 1 proton in the nucleus. It doesn't have 2, it doesn't have 0, it doesn't have 5. Always, if there's only 1 proton in the nucleus, the element is hydrogen. Its atomic number is therefore atomic number 1. Elements are pure substances, and they consist only of atoms with the same atomic number, okay? The atomic number cannot be changed, or you would be changing the element. The numbers of protons, neutrons, and electrons will be used to predict how each element behaves and different classes of those elements. You'll see as we learn about isotopes. Each different chemical number has a different number of protons. So we're going to kind of belabor these points just to keep driving them through our heads so that we remember them. The atomic number is the number of protons. Now we're going to learn a new term, which is the atomic mass. The atomic mass is obviously how much this atom will weigh. And the weight is made up of the number of neutrons plus the number of protons. Electrons really don't add any mass to the atom. The weight of an electron is 1,836 of a proton. So you can see it is negligible compared to the mass of the neutron and the proton. The periodic table of elements was discovered or invented by Dmitri Mendeleev, and it is an arrangement of the elements by their atomic number. So you'll see the first element is hydrogen with the atomic number of 1 that we've already gone through. The second one, all the way across over here on the other side, with an atomic number of 2, is helium. Helium, therefore, has 2 protons in its nuclear core or its nucleus. Okay? Lithium is in the second period or the second row, and it has an additional proton. So it has 3 protons in its nucleus. You can see that each element is represented by a symbol that's typically related to a Latin or Greek name for that element. Again, to belabor the point, because we're going to get confused on it, the atomic number, which tells you which element it is based simply on the number of protons and only the number of protons and nothing else. You can see that the atomic number is represented up here for oxygen by atomic number 8, okay, above O, the symbol for oxygen on the periodic chart. The atomic mass is the number of neutrons plus protons. So here we see the atomic number for oxygen is 8, meaning it has 8 protons. Its atomic mass in atomic mass units is 15.999, or for all intents and purposes is 16. And you will see that 16 minus the 8 protons will give us 8 also neutrons. Okay, here's a good representation of our atom. Once again, using the form that we know very well, okay, that we just saw in the last picture. We have our protons represented by the light green particles in the nucleus, and those are positively charged. We have our neutrons represented by the dark green particles in the nucleus, and those bear no charge whatsoever. So our atomic number, once again, is based on the number of protons. Our atomic mass, or the weight of the entire atom, is based on the total number of protons plus neutrons. our electrons do not bear for anything in our atomic number and our atomic mass. Our electrons are important, however, for chemical bonding and reactivity. Our electrons have the negative charge. Once again, to review, our atomic number for oxygen is represented by the number 8, which is above the symbol for oxygen, which is O, and the atomic mass is 16. Okay, our atomic mass is our number of protons and neutrons. And this becomes important when we start looking at isotopes. So if we hold our number of protons constant, we can add in more and more neutrons and change the weight. You've probably heard of things such as heavy water. Heavy water is a water molecule in which the hydrogens have additional neutrons in the nucleus, okay? So isotopes of oxygen. We already looked at oxygen 16, which had 8 protons and 8 neutrons in the nucleus. If we look at oxygen 15, we know that it has 8 protons because its atomic number is 8. So 8 atomic number equals 8 protons. The remaining mass for oxygen 15 would be taken up by the 7 neutrons, or 15 minus 8 equals 7 neutrons. Oxygen 16 we just went through has 8 protons and 8 neutrons. And can you figure out what would be the composition of oxygen 17? Okay, and notice for our isotopes, we put in a superscript before the number or before the letter that represents the atom. We put in a superscript the number for the weight of the isotope that we're talking about. So for oxygen 17, we would have 8 protons and we would have 9 neutrons in the nucleus. I hope you got that one right. Here we have isotopes of hydrogen, oxygen, and carbon. So our normal hydrogen has 1 proton in the nucleus and no neutrons. This is hydrogen 1 with the superscript 1 just before the H, the letter that represents hydrogen. Its atomic mass number is 1, so therefore it has 1 proton. Its atomic weight is also 1, so therefore there are no neutrons in it. Hydrogen 2. Can you figure this one out? Okay, so we know its atomic number is still 1. Hydrogen always has 1 proton in it, no matter what isotope it is. If it's the element hydrogen, it's always 1 proton. Any difference in protons mean it's a different element. So hydrogen 2 has a neutron in it. So 1 proton plus 1 neutron gives it an atomic weight of 2. Hydrogen 3 has 1 proton, of course, with its atomic number of 1, and it would have 2 additional neutrons in it, okay? And you can see this heavy, very heavy hydrogen is a cosmogenic hydrogen with a long half-life. We already did oxygen. See if you can figure out all the carbons, okay?